Hi everyone, this video is an exercise 14a of pure 1 question 4. So for each statement, we want to decide whether this is true or false and justifying your answer or offering a counterexample. Right, so one thing is that always remember that for true and false questions, you normally need to justify your answer if it's true, or just sometimes you need to even prove it. But if it's false, you can only just give a counterexample and that's enough. So part A, the graph of y is equal to a to the power x passes through the point 0, 1 for all positive real numbers a. Okay, so if you want to see that whether point passes, whether basically a curve passes through a point, we just need to substitute the coordinates of that point into the equation of the curve. So in this case, we substitute we can obviously substitute the x coordinate and then we are expecting to get the y coordinate. So if we substitute 0 and we get 1, then that means that this graph passes through this point. Otherwise, this doesn't. So now we can substitute 0. So we have a to the power of 0 and that is equal to 1. And that exactly is equal to the y coordinate of the point. So since they match, then that means that this point is indeed on the curve. So this is true. Now for part B, the function f of x is equal to a to the x is always an increasing function for a is equal to positive. Now this is the case that we just need to try different values of a. So we can always try positive values of a, which are let's say values such as 2, 3, 5, so any whole number, or it can even be other decimals basically. As long as the number is 1 or greater than that, then this function is actually increasing. But if we consider the case that let's say a is equal to a half, then in this case, so f of x is equal to a half to the power of x, then this no longer is increasing. And that's a problem, right? So that's because what happens here is that as you increase the value of the x, then the function keeps decreasing, because when we increase the power, then this number, which is between 0 and 1, it just keeps getting smaller and smaller. So because of that, this is actually is not increasing. So this is just a counter example. Now part C, so we want to see if the graph of y is equal to a to the power of x, where a is positive real number, never crosses the x-axis. So when we this was a previous example that we had y is equal to 1.7 to the power of x, and obviously a in this case is a positive number. And as you can see, it actually never crosses the x-axis. So x-axis is just an asymptote, and that's one of the properties of exponentials of the form y is equal to a to the power of x. So this is indeed true, because when a is positive, then a to the x is always so true, because when a is positive, then a to the x is also greater than 0 for all values of x. Because when you consider the asymptotic behavior, as x gets more and more positive, you're going to have a massive increase in terms of the y values. But as x gets more and more negative, then your graph approaches 0, but it never reaches the x-axis.